we have a sample of 10 fibers from a collection of, let's see, so our total is 92 fibers. We have 43 fibers of polymer A, 17 fibers of B, and 32 fibers of C. So this is my pool from which to draw, and it appears that we are drawing 10 fibers overall. Now, looking at this problem, you would have to decide whether or not you're putting things back. I'm going to guess that we're not putting stuff back, just the way that it's worded. Okay, and specifically since it doesn't say with replacement. So A says, what is the probability that the sample does not contain any fibers of polymer B? So, probability of no B's. Okay, so you said you wanted to just do this with straight probabilities. So, intuitively, how did you want to do this problem?
Find the probability of A, B, and C, and then
okay, so this is what I would think of if I was trying to find the straight probability. Is I would say, okay, so if all of them have no B's, then that means the first one is no B, the second one is no B, third one needs to be a no B, etc., all the way up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I do this for 10 of them. Okay, so on the very first one, what is going to be the probability of getting something that is not B? Okay, so not B is 43 plus 32. I guess I could do that in my head. 75. 75 out of our total of 92. So for my very first draw, to get a not B, there are 75 possibilities out of 92. Okay. But on my second draw, how many not B's do I have to choose from? 74 out of 91. My second draw will be 73 out of 91. Next draw, 72 out of 90, 71 out of 89, 70.
We should change this.
I did 91 twice?
Yeah.
Thanks. Okay, so let's try 73 out of 90, 89, 88, 87. Let's see, so this is going to be 69, 68, 67, 66, 86, 85, 84, 83. Okay. At this point, it's going to take a little while to put in, right? But we can try it.
Could you do like 75 over 92 factorial divided by 65 over 82 factorial?
Okay. Well, if I do 75 factorial, it's going to do 75 times 74 times all the way down to 66, and then it's going to keep going.
But if you divided it by 65 factorial?
Okay, so you want to do 75 factorial over 65 factorial?
And does that work?
Yes, that should work. Okay, so that might be faster to try that. And then 92 factorial over 83 factorial. No, 82. Okay, so maybe someone tried the long way. I'll try it this way. Let's see if we get the same answers. Oh, I think it believes that is too big to work with.
It says overflow or something like that.
Yeah, so I keep getting math errors. So this is too big to even put in my calculator. Okay, so then let's try a different method. Okay, because you said you wanted to just try the straight probability and the book was using the combinations. So let's look at what the book has and see if we can figure out why this appears to be the same thing. Okay, so the book says, or the solutions manual, We say, okay, well, we want to get no B's. Okay, and we assume on this the order doesn't matter. Like, we're just drawing fibers out of the bag. We probably don't care which fiber we draw first or second. Okay, and so we say, okay, well, I need to choose 10 fibers that are not B. Okay, how many fibers are not B to start with? There are 75 not B fibers, and I need to choose 10 of them. Correct? So this is to get not B's. And then we say, okay, well, that's just the number of ways to get not B. But you need to divide that by the total number of samples. So for the total number of samples, you'd say, okay, there were, what, 92? 92 total fibers, and I was choosing 10 of them. So if I wanted to do it just this way, I say, okay, what's the total number of samples I could choose, and then what was the number of ways to choose something that is not B? So number of ways to choose something that's not B, number of total samples. So hopefully I can put this in my calculator. Okay, and it will actually give me an answer. It gives me 0.1149. Okay. Now, so this was using the combination. Now, if you actually work this out, okay, and use the combination formula. So this is 75 factorial over 10 factorial times 75 minus 10 factorial. Okay, over 92 factorial over 10 factorial times 92 minus 10 factorial. Okay, what are those 10 factorials going to do? They cancel, and we get 75 factorial over 65 factorial, okay, times, let's see, 82 factorial over 92 factorial. And when you start simplifying this, you actually get 75 out of 92 times 74 out of 91, down to 66 over 83. Okay, which, notice, is the same thing we tried to do intuitively, but it did make it so it was big enough that I could, small enough I could put it in my calculator. Okay, so as far as the test, you may do it this way, or you may do it the second way, and I will make it small enough that either way will be something you can put into your calculator. Does that answer your question of why you want to do it that way, but the book does combinations? Okay.